Hello again. This is a short tutorial about statistics on words in your books, and this is much more interesting than the characters, of course, and we will continue on that track intensively. But this is the first step just to get used to it. So we have our setup here, make a new chapter in our book, Statistics on Words. So again, we have to set up our environment. What do we have? We have our pop-up menu. And we have the book selected. So go here and have the book selected. So if we put that to dynamic, as we've seen that's locker ASU, now it's Leibniz. So this is our interface. So we had a proper version of how to load the text in a fast way. So we have, this is our text with book selected, import from our library, all this worked properly. So therefore with Leibniz we have the text. So close, and this, now we want to continue. So string length to check the text. 1,000,000.1 characters. That's fine. Forget that. Now we want to split this text into words. What you do is that you identify a list of characters which are with words and the other characters are splitting words. So, and this is word space word character. Let's look it up. These lists are predefined. Get help. Word character, word space character. This is what I'm interested in. Word space character. Okay, now word space character. It's small. A white space character. No, word space. Word character. So, this is a word character. Now, we have this command word split, string split. We can look that up as well. So we have a string and a pattern. So let's have a test. So it's A45ER. So you see this is, then we got a string into a list of certain elements. Then we can get the first one, the second one. Close this, that's the 4, 1, 4. So a proper split is this. We can split the text with not word characters. So if it's not a word character, we want to split. So this is not means except and word character, I'm not sure. It should work like that. Here we are. Good. Now we have 190,000 words in this list. So we call that words. Good. Now there's a lot of words these short things and so we don't want to have. So therefore we want to make a selection of words longer than 3 characters. So this is select off the words, and then we say string length of each word should be greater than 3, and this should be a function, which means we take all the elements of this word, get it through this test from here to this variable, ask the string length. If it's positive, it's true, then keep the word. If it's not false, leave the word. So sim select. Now we have, you see, these small things are gone. We call that, because the C sequence, the production line, we call that words 1. So that's the first thing. And then there are so-called stop words. Word data, there's a database of words. So you can look for, so it's a lot. You can ask each word what it is. For example, here, what is a fish? Now it's loading the databases, so all this dictionary stuff is there. So, and word data, and we look for all, and then they are called, so these are stop words we don't like. Stop words, hopefully this, yeah, here. These are stop words which have no semantical meaning. So therefore we say these are stop words. So, and we make a similar thing like here. So this is now the list, it's production line from 0 to 1, now from 1 to 2. And we again select words 1 if it's member queue. If this thing is member queue, look it up what it is. Get help, member, list and form. So list, form. So member queue, stop words. This form, this single form, and make it a function, a pure function. So same procedure, and here we are. So we have 35,000 words left. So that's good. Now there's a function called counts on list. We count says if there's A, B, C, A. Count says 2 times A, 1 B, like we had with a character. So it's counts on expressions on lists. So counts on these words. And we take that, there it counts. You see it's super fast, but it's not sorted. So we make sort and check it. So then it's sorted, but it's, something's wrong, huh? Aha, we had 35,000 stop words. Member queue, we want to have not member queue of that. So I was astonished. So therefore we have all the stop words here, counting of the stop words. Now this is not, here it's good better. So now we have this 11,000 different words, and in the wrong sequence, reverse of this sort, now we have good, reason, evil, things, fail, and so on, translator. That's good. What we should do is that we have capital and lower letter, and they are different now. Now, therefore, we should have a list called word 3 is 2 lower. Okay, or let's ask what it is. So, Mathematica. Change string to lowercase. And there's this command to lowercase. You see it's here 2 lowercase ABC. This is the same thing like if we say 2 lowercase here, we can get, just to remember how to use the internet. If you don't know this name, ask it via Google. So 2 lowercase is this, and we want to have it for each word. So not for the list, but for each word in the list. So very clear, working properly. And now we have another setup. You see God's, you see it, yeah? Good, evil, and now we have God's. That's our list, sorted list. So take the frequent words. Word 100, for example, is, now we take counts and we take from 1 to 100. These are the most frequent words we have. Good in this book. Now there's, for example, word cloud of word 100. And here we are with the word cloud of this book. Simple. Now again, making a comprehensive function, go for a new document and select everything. So we want to have him, text, take the text. Okay, we want to have the words. We want to have 1. We don't want to see the result, therefore we need the semicolon. Words 1, stop words, we keep that. So we should make that with a dollar, because it's global. So no return. Okay, that's working. Counts. And the word 100, or words 100, better. Words 100. We have that, and here we want to get the word cloud. So what takes the words 100 and make a function of this thing. So empty C, book, words 100 of the book name, and take that as variable and put it into the function. Now we have to wrap the variables and close the whole story. So here we have close. This is not defined yet. Now we have to save the variables. Oops. Counts. And this is our result. So, and we can have words 100, that's good. We could do a variable here, but 100 is fine. So these are words 100. This again is a function, but first check it whether it's working. MTP book words 100 of book selected. Here we are. That's good. Fine. This takes about a second. We can check it again with timing. And this is not good. It's 1.5 seconds. That's too much. So therefore we save that. But first, okay, we want to save this. Again, we have the MTP library. We need the book selected. We need, we put it in our small data set. This would be the best idea. So, and then we have that book selected dot, how do we have it? Meta. So, therefore we have to import. This is a meta file. And this, a meta file, import, meta is import, is to expression. No, first show the meta file. We have to look it up. It was too spontaneous. Import metadata from book. So we simply do this. Not good. Comprehensive functions. Here, book name, book read, book select. Here we are. This is our thing. And now we want to add one new attribute. So this is with an append to read data. And then we say we want to have words 100. And this is here. Hopefully this works. Here we are. So this is our list here, source, name, and then words 100, and here. That's good. And then we have to write this data back. So this is write data, write metadata write of read data extended, and this, fine, the second, and this is read data extended. So if we now look it up with that Leibniz, metadata extended, here we are, with all the words in there. Good. So, this is our function. So we have these counts, 100, okay, but we need the read data in here as well. So clear that. These are the read data, and this is a new thing here. Read data extended here, and write this data extended. This is a local variable. Write that. So, and now we have this book selected. This is book name. It counts. And here we simply say this is the counts. And from 1 to 100. So, and return the counts. This is side effect, and now counts 1 to 100. So now, word, here we are. That's it. That's good. Copy. Okay. Now, this is our comprehensive function. Now we put that accessible, so this is available. And now our word cloud needs this. Word cloud, word 100 now is directly from this file, so which means we have the book selected. Now we have MTP meta read book selected. It's here. Put that into brackets and go for the words 100. Here we are, very fast. You see it's nothing, 1.5 seconds, and here it's nothing. You can do it, it's 200 times faster. So, and now we have the word cloud. Of this. Yeah, that's it. Yeah. Now with the thing here, we need to do these words for all the books selected, for all the books. Look how to get the book list. Work on the library. It's here. Select 5. This is the function. Here. We need this no, these are all our books, but we need the directory to set directory to be sure to MTP library. So we need this library, and then this works. So this is these are our books. Okay, now we have to do the book reads to get all the data for an update to all the metadata. We have to make book reads to all the books. This is fast. It's meta read. No, we want to have the book words. Book words to all the books. 10 books, 1 to 2 seconds each. Here we are. Forget this stuff, and now this should work. With our pop-up menu. And go here for book selected. We don't. Yeah, words. So this is now word cloud over this. If we go for Locke, if we go for Montagne, not working. Book name, here. Book name, here, book name, book name. Okay, save that, save the whole thing, and make an update here. Now we need an update here. So we had all these metadata updated with the wrong function, all referring to Leibniz. Therefore they have all, so these are all the books. Now okay. Now we take Pascal, that's working, and still not working. Word. Here, word. So, books is good. Here. Yeah, now it's better, hopefully. And now we are with Pascal or Newton. Book selected, and words, word cloud here. Color, light, rays, glass, prism on the optics of Newton, Spinoza, mind, nature, proof, body, and so on. So that's it on the first statistics on books. Thanks for watching. Hope we see you next time.